We are actually going to do the second 10.6 lesson today, so go ahead and flip a page ahead in your packet to where we have all of the graph grids. We're going to do the second half of the 10.6 lesson first. It's a little bit quicker, and so given that we have a short class period today, we're going to do that one instead. So in this lesson, we'll be looking at graphing conics in standard form, which means that the centers are not necessarily at the origin. Find my chart here. Apparently I don't have my chart in my PowerPoint. So there is a chart at the top of your notes, and that tells us how we can move around centers to different locations. So up to this point, we've studied all four kinds of conic sections, but we were always right at the center of our graph. So in this lesson, we're going to look at how we can move those centers away. And the key to all of those equations is that there's now an h and a k somewhere in the equation. H comma k is going to be the center of our graph. So when we see an equation like this, we want to find what matches with this in the chart. So first we need to determine what kind of an equation this is by matching it up with an equation in the chart. And what does this one look like? It's the equation of a circle. So the general form of the circle is x minus h squared plus y minus k squared equals r squared from the chart. And you don't need to memorize this chart again. When we come to the test, you'll have the equations provided for you. You just need to know how to recognize which is which, and then how to actually put them onto a graph. So HK is the center. So that means the center of this circle is going to be at 3, -2. It's the opposites of the numbers in the parentheses, because the standard form of the equation says that we have x minus h and y minus k. So we're looking for the opposites of the numbers in the parentheses. So our center is going to be at +3, -2. So in our graph then, we're going to go over to +3, -2, and that's going to be our center. The only other important feature of a circle is its radius. So what is the radius of this circle going to be? 4. Because if x squared plus y squared equals r squared, then 16 should be our radius squared, which means our radius is 4. So from your center, we're going to go 4 in each direction. So 4 out to the side, down, the other side, and up. And to get a circle, we want to connect those dots.
So once you figured out the center, you kind of can ignore that side of the equation?
For a circle, once we found out the center, the only other feature we really need is the radius, so we can kind of ignore that side. Yeah. So the center is at the opposite of the numbers in the parentheses, and then we want to find our radius and count out from that new center. For this one, this is a circle again. It has the same format as the last one. Where's our center going to be? 1, 4. Opposites of the numbers in the parentheses. The other important feature of a circle is the radius. And the radius for this one is going to be 3. Our equation is equals r squared. Then 9 is r squared, which means a radius of 3. So from that center, I want to go 3 in each direction. And connect around to make as circular of a shape as you can. Questions on circles? What kind of a conic section is this one, and how can we tell?
Hyperbola because there's a subtraction in the middle.
Hyperbola because the subtraction in the middle. So we can still make it into a fraction. We want them kind of both as fractions for either a hyperbola or an ellipse. The important feature of this one here is the subtraction in the middle tells us that this one's going to be a hyperbola. The center is going to be found in the same way, opposite to the stuff in the parentheses, but pay attention to what letter's coming first here because we need to adjust for that. So your x should come first. So with the x in this equation is going to give us a -1, and then the y in this equation is also going to give us a -1. So here it doesn't really so much matter because they were the same, but it's important that you do pay attention to that because most of the time it is going to matter. So the x needs to come first in the point. So our centers are the opposite to the stuff in the parentheses. So for this problem then, our center is going to be -1, -1. And we just learned about hyperbolas yesterday, and we learned that what letter comes first determines our direction. So a y coming first means that this thing is going to face vertically. It's going to be in the up and down portions. To find out where those vertices are, we want to take the square root of the number underneath the y. Square root of 1 is 1. So we're going to go 1 away from that center, and that makes our vertices. Then, underneath the x is a 4. What do I want to do with that? Take a square root of it again, and I get 2. And what do I want to do with that?
Is it covertices?
It's kind of like the covertices. We don't really label them as points in an ellipse. It would be our covertices, but it's still our sideways movement. So we're going to go sideways 2. And then what do we do for our hyperbola?
Draw a square.
Connect them with a rectangle. Then we draw in the diagonals of that rectangle, which define our asymptotes. And the curve then follows those asymptotes and hits the vertices.
How do we know which way the curve's going?
That is like top and bottom instead of the sides. By the letter that comes first. So since y came first in this one, that means it's the top and bottom section. If x comes first, it means it's the sideways sections.
How do you know how wide it is? Is it not based upon anything in the equation then? It's just following the asymptote?
Just following the asymptotes. Yep. Right, we'll do another example of a hyperbola. So again, we can tell this is going to be a hyperbola by looking at it because of the minus in the middle. So that tells us that we're working with a hyperbola. Because our y comes first tells us that this one's going to be a vertical one again. So we're looking at the top and bottom sections here on this one. If x comes first, then it would be the left and the right hand sections. So first thing we need to plot is the center of it. Where's the center going to be?
2, 3.
Careful about the order of the
3, 2.
numbers. 3, 2. The x has to come first. So it's the opposites of the stuff in the parentheses, but x always has to come first in our points because they're alphabetical. So our center is going to be at 3, 2. Then underneath the y, we want to take a square root of that, and that tells us how far to go in our y direction. I go up and down 2 to get my vertices. And underneath the x, take a square root of that, gives 3, and that tells us how far to go in the x direction. Connect them with a rectangle and fill in the diagonals. And the curve, because y came first, is vertical, so it should be into the top and bottom sections. And then notice again, we just learned these yesterday, and I mentioned it yesterday, but notice again, it does not go all the way into the center. So often students want to bring these things all the way into the center of that x. Right? It does not go within that rectangle. That kind of serves as a boundary for it. Questions on hyperbolas?
Do we need to plot the foci?
You don't. No, you don't need to plot the foci because they're not critical in coming up with the shape of the curve. What is this? An ellipse. We can tell it's an ellipse because the plus and because there are fractions. Okay? A circle also has a plus, so like our first ones were circles, but because the numbers that are underneath the x and the y are different, that creates an ellipse because it's more stretched in one direction then. If those numbers are the same, then it's equally wide and tall, so then that's a circle. A circle is really just a special case of an ellipse. First thing we want to plot is our center. Where is that going to be? Negative 3, 1. Opposites of the stuff in the parentheses. What do we do with the number underneath the x? Square root it and do what with that value? It's at least our sideways movement. We can determine later whether it's the vertices or the co-vertices in terms of what's bigger, but at least because it's under the x, it's going to move us sideways. So we're going to go sideways 1. Underneath the y, same thing. Square root it, gives 3. And since that's under the y, it tells us about y movement or up and down movement. And then for an ellipse, we just connect around. So then technically, the bigger ones are the vertices and the smaller ones are your co-vertices, but you don't really need to label them. You also don't need to find your foci because they're not critical to the curve. Questions? So an ellipse is kind of like a hyperbola. We plot the same things, except it's easier because instead of doing the rectangles and the x and stuff like that, we just connect around. It's going to be another ellipse that has the same format, the plus in the middle and the fractions. Where's the center of this going to be?
2, 1. Negative 1.
0. There's nothing with the y. It's not added or subtracted to anything. It's just a y. So that's going to create a 0 there. It's like y minus 0. So when you don't have anything with your variable, that says that it has no movement at all. So it stays at 0. So center is over 2 and up 0. Underneath the x, take a square root. Gives 5. So we're going to go sideways 5. And that's going to make either our vertices or our co-vertices, and we can worry later about what they are. Underneath the y, take a square root, is 2. And since it was with the y, it tells us about up and down. Connect around. The smaller ones are technically the co-vertices, and the bigger ones are the vertices. But you don't really need to label them. Questions about ellipses? That leaves one conic for us, which is a parabola. You can tell we have a parabola when we have only one variable in the equation squared. So in this one, only y is squared. To tell whether it's horizontal or vertical, you're going to want to check out that chart and see if y is squared, which way the chart says it faces. So if y is squared, which way is this thing facing?
Horizontal.
A y squared is a horizontal facing. So looking in the chart, we're looking for the one that has the format of y minus k squared equals 4px minus h. And that falls under the horizontal column. So this one's going to be facing horizontally, either left or right then. How can we tell just by looking at the equation whether it's going to be left or right? The negative. The negative is going to tell us that this has to face in a negative direction, which would be left. Where's the center? Well, it doesn't really have a center. For a parabola, we just need a vertex. We don't really have a center of a parabola. Where's the vertex going to be? It's like the center.
8, 6.
8, 6. So 1, 2, 3, 4, 5, 6, 7, 8. It's kind of a lot. I'm going to count these by halves. There we go. They're kind of tall boxes there. So 8, 6 is going to be our vertex. We don't really have a center. Then what we need to do is find our p-value to find our focus and find out how wide this thing opens up. That number multiplier in front of those parentheses should be equal to the 4p. So negative 4 is equal to 4p. Means p is equal to negative 1. P is the distance from the vertex to the focus, and it's directional. So since this thing is horizontal facing, I'm going to go sideways negative 1 to get my focus. And opposite, I'm going to go sideways positive 1 to get the directrix. One is considered to be like a standard p-value, so this is going to be not wide and not skinny. It's just going to open up around that focus. Okay, so parabola behaves a little bit different than the other ones in terms of we don't have a center, we just have the vertex. But the vertex is the same value as the center would be, the h comma k. Then we want to find our p-value to plot our focus and our directrix. We use the chart to determine direction. If y is squared, it's horizontal. If x is squared, it'll be vertical. It seems a little backwards. Let's try another one. So this one's going to be a parabola again because only one of the letters is squared. Is it going to be a horizontal or a vertical? Vertical because the x is squared. So in the chart, x being squared falls under the vertical. Where's the vertex going to be? 1, negative 3. Opposites of the stuff in the parentheses. So 1, negative 3 is going to be our vertex. The standard form says x minus h squared equals 4py minus k. So that means that our multiplier should be equal to 4p. Which means p is 2. And since this thing is a vertical facing, I'm going to go up 2 to get the focus. And opposite, I'm going to go down 2 to get the directrix. 2 is bigger than 1, so that means that this one should be a little bit more of a wide parabola. We would need to find some more exact points and plot them if we wanted to be really specific about how wide this thing is. And we're not going to do that. So it's just, we're going to consider it to be a little bit wide, kind of sketched out that way. Questions? Okay, so your homework is numbers 21 to 28 from 10.6 tonight.